Hey there, welcome back guys, and we're live, and today we're going to be building a transistor radio. That's right, so you've got your favorite tunes or your jukebox, whatever you want to call it, and you have your don't touch that dial because we've got your favorite radio station coming right up. And this is part one. There's going to be a two-part in the live stream because we want to test out the parts. As you saw in the previous experience, it took three tries to get the glasses done, but it wasn't because we didn't know what we were doing. It was because the parts they sent us were actually dead. A lot of dead LEDs, one dead capacitor, which putting in one dead capacitor to complete the series circuit, it's not going to light up because it's simply dead. So we're going to test the parts before we move forward, and once we test the parts, probably the next live stream may happen this weekend or next week. We will build it, solder it, and put it together. So without any further ado, let's get started for the transistor radio. All right, so as you can see here, let me just switch the screen so that you guys can see what's happening. We have the parts already laid out. So, and you want to do this at first. You want to make sure your parts are laid out, everything is good to go before you go, because this way moving forward, everything is where it needs to be. It's easily accessible because you want your parts to be accessible as you're building it. You don't want to scatter around looking for things and like, oh, there's that part. Oh, there's that part. Just turn off here. You want to be able to just like grab and go, and you can't do that if you're working out of the box. Okay, so without any further ado, let's see. We have our little microscope. You're going to need a microscope or really good vision or glasses, which I have over here to do this soldering job on this one, because there are no prongs moving into the board. You're going to be soldering the crystal / chip directly onto the board. So that part's a little bit challenging. It is a beginner, I would say, but you're just going to require, you might need, I'd probably recommend a little bit of painter's tape so you can tape the chip onto the board as you're soldering it, and I'll explain why as we move forward. And you'll be like, tape, why do I have to tape it? Because one little tap can throw the board off, and then you'll either bridge a connection on the microchip or not have it in its right area because it's a little bit off, but you'll see. Knowing that, and like I said, moving forward, let's go over some of the parts. Okay, so this device right here is similar to a multimeter, but it allows you to test diodes and transistors. So it's a diode, transistor, an LED, also known as LED tester, okay? And you can also, this is a transistor right here, in case you're wondering. See that? Okay. And we'll have a look at them under the microscope so that you guys can see. And speaking of under the microscope, let me just eject some drives that I have connected to my computer so that we could actually use the microscope. I believe the microscope can be used wirelessly, but we're just going to hardwire it for the experience so that it's just right for you. All right, knowing that and moving forward, just going to plug this out and plug this in here, and this way we won't have any glitches with the connection. But again, the microscope does work wirelessly. Okay, so I'm just going to turn it on. All right, and then we'll go through some of the parts. And let me go here. And the name of the application is called Quick Camera. I'm going to do a video on Quick Camera because it's a great resource that actually allows you to view your microscope. Now, by default, the microscope tells you to use photo booth, but everything in photo booth is in reverse, and it's not really ideal for the experience that you want, especially when soldering something like this. As you can see, is this the microscopic view? No, that's the camera view. Hold on one second. So then I have to choose my camera. One moment, please. Stand by. Quick camera. Hold on. Select source. So I'm just going to select the source. I'm like, wait, that's a pretty good microscope. But no, that's here. All right. And then now if I switch it to the microscope, and there we are. Let me explain to you this right here. Let's see if we can zoom in or out. Right about here. So this is where the crystal goes. And as you can see, you got a soldering joint here, soldering joint there, soldering joint there, and there. And this is the part that's going to be really tricky, and I recommend having painter's tape. Any tape that's adhesive, but not like duct tape. Definitely not duct tape, because you can actually ruin it. Painter's tape is actually gentle, and it'll allow the experience to be fluid, so that you could move forward without ripping the board apart as you take the tape off. Okay, knowing that and moving forward, looks like we need to put Louis in another corner. But remember, nobody puts Louis in the corner. All right, here we go here. I'm gonna move myself over here. I believe this is a good enough spot. Well, just so you can see the chip a little bit better. And this is it. Now, we don't have a tester for this, so this is pretty much, but it tells you the way. You see right here? That's where the crystal is, okay? So the crystal's right there, and then the chip is there. So you put it corresponding to its piece, you know, to its layout. And you see how I move one finger, I pick it up, my finger sticks to it, etc. And as you can see, you have to line all that up, and you have to line the other side up too. Now this is a tricky part, because I believe, no, it shouldn't be too tricky now, because nothing is backwards. See? So knowing that and moving forward, what we probably want to do is cut a piece of tape so that it sticks on there, because you don't want your solder joints to move as you're soldering it, because if you tap it, and you're going to need a soldering iron with a really fine point. Any soldering iron will do. You don't have to go out and buy a new one. Just make sure you buy a finer tip, so that when you tap it, right? So when I go tap with my solder, see? When I go, let's say, try it here in the bottom, tap with my solder, it's not going to move. It's just going to melt and blend it together. And if you have shaky hands, I don't have, my hands shake a little, but not a lot, but I get nervous sometimes. Anyone's going to get nervous. So again, you want that painter's tape, and you want to make sure it's aligned. So you'll get, oh, it's DJI support. I told him that I would be flying my Neo today, but actually I'll have them call back. Hold on one second. One moment, please. Hi, how are you?
Hi, this is Jessica calling from DJI. I'm doing good. Thank you for asking. How about you?
Not bad, Jessica. So I didn't get a chance to fly my drone today, the Neo. Can you call me back? Only because it's raining and it hasn't been sunny weather. Can you call me back on, I believe I should be back on, how about Monday? Because there's a holiday tomorrow, and I don't see myself flying tomorrow. Can we do Monday?
Sure, not a problem.
Thank you.
I'll be calling you back on Monday, and please have it through the test. But just in case I will not be able to reach out to you on Monday, I'll be sending you an email instead, okay?
Yeah, no, but please do, call me, because I need, you need to know, I need to know it works, and then you need to know it works, so that I know whether to send it back or not. Okay?
Sure, not a problem.
Yeah.
I will take note on this one.
But what's the, sorry to cut you off, but quick question. What's the story with the Neo? Like, is DJI aware that the drone flies away and it's not as fluid as people expect, and it crashes, and not by pilot error, but just by, the firmware
manufacturer
issue?
error?
Yeah, manufacturer error. Yeah, are they aware of that?
We are actually checking, let's say, the moment that customers, regardless of what drone they have. So basically what will happen is that we will go ahead and check if what seems to be the issue. But since it's Neo,
right?
So we are still checking on it. But as of now, we are in our department, we are unable to confirm it yet. Definitely, if there would be progress, if there's a need of firmware updates, so for sure you will be aware of that one as well.
Great.
But right now everything is good with our Neo. We've been receiving a lot of feedbacks. I mean, good feedbacks with that drone, because it's very portable and very useful even with youngsters. Got it.
Okay. All right. Thanks so much, Jessica. I appreciate that.
You're welcome. So, anything else to get assist you with?
No, that's it. You've been helpful. I'll talk to you on Monday. Okay. Yeah.
Sure, not a problem. Thank you so much for your time, and happy holiday.
Thank
Goodbye.
you. Bye. Right. So on that note, they've heard nothing but praises, nothing but it's such wonderful experience. Meanwhile, even my viewers and subscribers are experiencing flyaways from flying it with their phone, flying it in manual, the drone just having a life of its own. But that's another video. So as you can see here, but I had to take that call, otherwise she won't call me back. Like they only call you back X amount of times, and after that your ticket gets dropped. All right, knowing that and moving forward, again, you're going to need a pair of these. I'll leave a link to this in the description. All right, just gonna put this over here to really see as you're soldering. Unless you can solder this way, you know, from the big screen TV, but even that part is tricky. So I'm gonna explain to you here. So as you see, it's a little even, not even, and if I bang it down a little bit up, no, it's off. If I bang it down a little bit down, it's almost just as good, right? That's good. And you can solder it like that. But the tricky part is, as you saw, you tap it and it moves. You tap it and it moves. So what we're gonna do is we're gonna take some painter's tape. Remember, we're only prepping it, measuring parts and things like that to make sure it works. So again, so that the experience is just right for you, because you're gonna have to do this. And I believe the first parts, are the hardest parts to put together. Everything else is a breeze. Everything else will be like putting together the glasses, or, you know, I think with the glasses there was no hard part. The hardest part was not knowing if it was going to work when you put the batteries in. But if you watch that video, we figured out a solution to that. Okay, knowing that, and this might be, I think this is good enough. So we take a piece of tape. It doesn't have to be that long, just long enough for the experience. All right, and then we're just gonna cut that. Hopefully that's not too short. And then run it from the top, right in there, into the middle. And we're gonna have to check it again because it's possible. Nice. See, now that's pretty good. We got some, and there was like a small microscopic soldering, you know, and that's why you need a pointier, thinner tip. Okay, knowing that and moving forward, that's one. And then you have another small microchip here. As you can see, it's so small, it's smaller than, here, I'll put it on my fingernail so you can gauge how, I'll put it on my other fingernail here. That's how small the chip is, and that's why you need either a microscope or really good glasses. But as you can see, I moved it a little bit, so we're gonna have to check it before we actually solder it. But let's show you how small this chip is. Okay, I'll put it on my fingernail. See, this one will be really easy to solder because it's a one-way. But again, we're gonna save that. We're gonna leave it in its wrappings and save this one for the next live stream, part 2. And then we have another chip, right, which goes on another side of the board, which is right here. So you see U3. This one's pretty easy because it goes in, which is weird, upside down. Sometimes the chip has a groove in it. This one doesn't, but the dot would go where the groove is, and then you would just do this. But again, there are no holes, so we're probably going to use tape on this one. Cut one really thin and then solder it. See how you have to line it up? So even if you line it up, you got to be really steady, right, with your hands. Whoops, see, because if I tapped it with the soldering iron, it's gonna move. So we'll tape that like that. Okay, and again, we're not going to be able to test the chip, but we just pray it works. But everything else moving forward will be okay. All right. And so now we have some other components here. I'm just going to run over with you. I believe that's it for the microscope part. The rest we'll do on the bigger camera. I'll show you the capacitor. These you won't require, whoops, any, see, a 104 capacitor. You got about 4 of them. Now the transistor. Sometimes when you have transistors, there are numbers on them correlating to the space that they go in. In this case, as you can see, there's the transistor. It's just nothing special, but you'll be able to put it into its spot because they're all the same. But you have to put them in correctly. So with the transistor, I'll show you under the microscope. As you can see, there's like a moon groove, right? The halfway point. So you have to put them in there to their corresponding shape. All right. So knowing that and moving forward, you find it. This is a capacitor, and then we're looking for the transistor. So there they go. I'm going to move this over to the side, and as you can see, hold on, where's my pointer? So the transistors go right here. See how that little round part is? That's how you would put the transistor in. Okay, and then don't worry, we're going to measure them in a second. All right, and then you have the 1K resistors go here, the 510 resistors go there. Go there, 510. Okay, and don't worry, I'll walk you through everything as we do it because this is more elaborate, many more moving parts. The buttons, S1, S2, S3, and S4 go along the top. And I believe that's it when it comes to microscopic views. The most challenging part is soldering those 3 chips that require either a microscope or a magnifying experience. All right, knowing that, moving forward, let's measure the parts, make sure they work so that we don't run into a disaster like we did before with our previous soldering experience. And then in part 2, we're gonna build it, right? Don't touch that dial. So in this case, I don't need the magnifier. I'm going to switch screens, but you can see that part is pretty challenging. The soldering the microchip onto the board. That normally most chips, come with connectors and you put them on. So it's a little bit different. All right. So knowing that and moving forward, everything else on the board I'm going to show you before we solder it. All right, and we're not soldering today. All right, knowing that and moving forward, let's go here. So here we go. All right, everything that comes in the box in your kit. So you have some transistors, which are right here. All right, I'm just going to shut this off. No need to keep this on since we're see the transistors. You got 4 of them. All right. Oops. A little screw. They'll probably tell us where it goes later. Micro USB-C. I wonder if I bought one of these, right? In a USB-C style, like if it would actually work. That would be cool, right? And then I can just swap it and not have to worry. But I don't know. It could be programmed for that to be hardwired that way. Looks like our camera is because I believe is the wrong, my screen is showing me something else on quick cam. All right, so that's the USB-C connector. Now we're going to start with testing a diode. That was our last nightmarish experience. So as you can see, we have a little tester here, and the LED, sorry, not diode, the LED is like a little light. And so we're just going to take the positive side. I have this little clip thingy. I got the attachment for this thing. It comes with an attachment. It has a negative thing. I'll probably make a new video on how to use this tester. It's actually really cool. And the negative side is the short side, right? And hopefully in the perfect world, actually, interesting. We had some parts here before, but anyway, you press this button. I'm not sure what I did with the old part. Okay, and then you press it to run a test. It says test in progress. This is a good sign because look, the LED is lighting up. Okay, the damage, it would say damage if it wasn't. Like if you saw our previous video when we put the damage part in, we got that, but I don't recall where I put them. So this is going to come in handy a little bit later because I'll have to test the parts so I don't mix them up. And it's probably in a bag or something. So we know that this LED is good. Great. See, look on here it says diode, which is just awesome. So we can put that piece down. Now for the transistor, I believe you're gonna have to spread its legs a bit. See that? And then we go here. and then open it, and then put, just follow along. Any 3 should give you a reading, right? So we'll go 1 red, hopefully, and then we'll go here, and then put the black one in the middle. I believe there shouldn't be any corresponding here. And then you press test, and hopefully the transistor should test, should tell us it's okay and good to go, or we'll get damaged. See, look at that. Oh, look at the little reading. Kind of cool, huh? And it tells you it's 624 millivolts, and then milliamps, and then 211. All those numbers are fine. No need to know what the numbers are because they will tell you where they go. And sometimes you will have to match the numbers, like a C for whatever 12, and then the numbers will correspond to their placement rather than the resistors have their ohms measurement on them. So that's good to go. Remember, we have to test all the parts because in our last solder build it just wasn't the best experience as we thought it would be. And this one comes with little clips, which is great. I took it out of the attic because I never had any trouble with any of our soldering builds until recently. I was like, you know what? I guess time to take this out of the box, like the keyboard. See, this one's good to go. That's 2, and I like these little clips because you can you don't have to finagle it like a bad game of Twister. It does come with an attachment so that you could use it on the board. The attachment's right there, but you have to hold it in a funky position. So that's 2. Okay, so that's great. This one was already tested, I know, because the legs are already spread. All right, and now I'm going to test the 3rd one, which is right here. Spread the legs a little bit, just spread it open, and then just so that you can get everything in there. And then I'm going to do this one, and then I'm going to do that one, and then I'm going to do that one. This is great. And just hold it from underneath, test, and hopefully we don't get damaged because I don't have any replacement parts on this, unless you have some old electronics laying around and you can take the parts from there, but then you'd have to measure it and find the exact same part, or go on YouTube, not YouTube, Amazon. So these parts are good, right? The LED is working, these transistors are great. Now we can check the capacitors. Okay, these capacitors, the ceramic capacitors, there's no right or wrong way, whoops, to put them in. Just don't lose them or drop them because you will be out of luck. All right, knowing that and moving forward, we got a solid grip, test in progress. And then now, let's see what we got. Whoops. See, 35 PFs. Okay, and then we'll just go here. All right, we'll put this here. Whoops. And then now, remember, we got to separate them so we know which ones work and which ones don't work, in case you have, because sometimes these capacitors look the same, just like the resistors. We've got about many of them. I don't even know how many, but I lost count, maybe 8 or 9. All right, knowing that, test in progress. And great, 35 PFs. And that's a good capacitor. I wonder what it says. I'm just going to put them over here on the right hand side. We got 2 more capacitors to check. See, there aren't many parts. And a lot of times, like I was saying, when the parts look the same, you will be out of luck if you mix them up. Well, not really, because that's why you have this thing here, right? And look, as long as we got the colors and we don't get any like damaged, test in progress. Nice. See, look at that. 37. All right. I wonder if I reverse it. Let's see if I reverse it. See what kind of reading I get. Put the black on the bottom, and it shouldn't matter. With the diodes, no, we don't have any diodes here. This will give you a reading no matter what, so it doesn't matter what position it's in. On the meter, you usually do. See capacitance, V-loss, 55 UFs. Interesting how we got a different reading. Let's try that again. Let's flip it over. And then try it this way. Test in progress. Oh, see that sometimes you'll get it damaged if it's not incorrectly. Oh yeah, it's not. Didn't clip on. So you want to make sure that the prongs are caught on there. Okay. See, there we go. All right, so we got one more. Usually with these it doesn't matter, but as you can see, we got two different readings in two different ways. Now we go for the next one. Put it this way. Let me just see what we have here. I'm just going to scroll in because it will tell you what their readings should be. Resistors 10K. Ceramic capacitors. It just says 104 ceramic capacitors. C1 just tells you where they go, in case you're wondering what I'm reading. It's right here. Oh, except we don't need that. Let's see, so you can see me. Yeah, so you see, in case you're wondering, right here. But it doesn't, those are the transistors, but the ceramic capacitors are right here. See? 4 of them. And 104 is their number, but their readings are a little bit different. So I want to see, and where do they go? So those ceramic capacitors go C1, C2, C6, C9. So look for C6 or C9 somewhere on the board. And if you can't find it, but even if you did, it doesn't matter because it's not giving us any reading. So we got to go scroll down a little bit and then look for where they tell us to put the capacitors. Right, ceramic, of course. Look for, or if you don't know, just look for the orange. See, there they go, right there. And it says, install 4-piece ceramic capacitors, regardless of positive and negative poles of power supply. So basically, it doesn't matter which way they go. Okay, and then knowing that and moving forward, and then it says mark ceramic capacitors C1, C2, C6, C9, and that's their placement on where they go. Okay. Let me just send out a text. Hold on 1 second. Okay. Knowing that and moving forward, so we tested the capacitors. It looks like we've got one more here under there, a little straggler. All right, and then now we're gonna go here. And then, you know, just put it in. So again, it doesn't matter which way they go, but what confused me a little bit was that we got 2 different readings from 2 different directions, one going one way and one going another way. So make sure your clips are on. Press test and let it work its magic. I'll come back to this screen right here. Hold on 1 moment. Great, and there we go, and it says unknown component, so it's possible that it didn't grasp on. Okay, and then you press it again. Make sure it's really tight, but you'll know if it's damaged if you know. That's a bummer. All right, let's see what we got here. Let's try it again. And the good thing it's a 104 and we have some spare ones. Wow. All right. 1, 2, 3, 1, 2, 3, 4. We got 4 104s. So we're going to try it another way. Just try turning around. It's a bummer. Damaged. All right. Just want to double check. Damaged. So we got one, is it a 104? P104? Yeah, it said 104. Damn it. See, and this is why you gotta test the parts. But I'm like, no, I can't be. I mean, maybe it's not touching. I don't know. The good thing is that we have an extra one from the other soldering kit they sent us. Must be part of the same manufacturer / distributor. Nope. All right, we're gonna try switching it. Wow, that's a bummer. And this is why you gotta test all the parts. Damn it. I'm okay. I'm disappointed and happy at the same time because we have an extra part on the other side over there from our previous collection of things that didn't work. We got a little bit of a reading, but why we didn't get one the other way, I do not know. But I would not trust this part for the life of me because, as you saw, it's coming up as damage most of the readings. Then see, now it's on the other side. All right, so let's try moving it up some. I'm going to try pulling it so that we can know for sure the parts are testing, like touching. You know, it's nope. So yeah, damn it. All right, but that's okay. Not all is gone, but I'm like, damn it, I have to use another part, which I don't mind using the other part, but I usually like the experience to be streamlined from the existing parts that come from the kit, if that makes any sense. All right, hold on 1 second, and hopefully yep, we have one, but hopefully this is we got a few 104s. Okay, so knowing that and moving forward, we got a little plastic baggie. What did I do with the one that doesn't work? Oh, it's right over here. So I'm going to keep the one that doesn't work over here so we don't confuse our parts. Okay, and then now let's pray that this 104, it's the same part, just different different experience, different kit. So it should be, and this is why, as excited as you are to build your stuff, you got to test the parts to make sure they work, so that you're going to put double the time in, but not so much. Test in progress, question mark. It should be working. See, and there we go. So same reading as before, 35 PFs, and then we're going to reverse it, and we got lucky here, you know. I'm just going to flip it over, test it both ways, only because, you know, I don't know, I just feel like doing that with the capacitor, just to make sure. And then now, all right, test in progress. See, and 35, same reading, both directions. All right, great, we got lucky there. Thank you, Amazon, for sending us the replacement kit because we kept the spare parts. All right, knowing that and moving forward, so we tested the capacitors. We got one dead capacitor, so you might want to mark it, because sometimes if you've ever seen me live stream, I've dropped parts and misplaced parts, and I'm just gonna color it in black, see, so that we know that this is the dead one, and then we'll throw it out later. Or you could send it back, right? We could be like, yo, it don't work. All right, so those are the capacitors. The transistors are good. We're good to go with those parts. And now, knowing that, moving forward, if we had soldered a damaged part, sometimes it might work. It'll get, like, you know, not enough power, or sometimes it won't work because you won't complete the circuit. Okay, knowing that and moving forward, you got to do the same thing with these things right here. As you can see, we have our resistors. Okay, this will be really easy because, as you can see, we have these little things we can put on here and then go there and just clip them on. This is the 510. Okay, so we're measuring. You could do this with a multimeter. If you have this attached with me, I don't have it. I only have it on this device. This is the LED transistor resistor tester. Okay, press it, and this is LED number 1, 510. We should be getting a 510 reading, and we got a 514, which is fine. We could live with that. And now we're going to move up one. Okay, and So we got 1. Press it again. Test in progress. Nice. 513. All right. More, I guess, is better than less. And then we have, remember, there's no rhyme or reason on how to measure them with the resistors. Okay. Test in progress. And that's 3. Nice. 514. On the last one, I'll show you. We'll get the same reading no matter which way we put the prongs to the meter. Okay. See, there we go. 516. But hold on 1 second. New tab. Yeah. I was like, wait, are we live? Just want to pop out for the chat. Do a refresh. Looks like we lost the pop out chat window. There we go. Nice. All right. It's gonna do a pop out for the chat. Close this window, and then close that window, and then leave this here. Okay. So yeah, great. 516, which is fine. It's doable. It's workable. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 9 resistors measuring at 510 or 513, 514, 515. You know, as long as 512. Okay, a little over is good. And then we'll go here, test it again. 3 more left to go. The last one we'll test in reverse polarity so that you know it doesn't matter. 506, which is good. And then we have here, we'll test this one. Just, I believe, the capacitors and 2 more rows of resistors. 510, nice. This one measured true to its form. Okay, this one we're measuring. Test in progress. Nice. 513, and the last one we're going to check twice. See if I have the black on the right and the red on the left. Let's see what reading we get. Again, it doesn't matter which way they go in, but if you like the colors pointing one way, do it that way. 509, see? And now I'm going to put the black on the left and the red on the right. And then press test. Test in progress. Okay. And voila, 509. So as you can see, it doesn't matter which way the resistors go in, but if you want it to be pretty and design layout to just flow with the colors pointing in their particular direction, you do it like that. All right, so knowing that and moving forward, whoops, let's move that there. So that's the resistors, okay, for the resistance. All right, knowing that and moving forward. Now we're gonna test the other resistors, which are the 10K, okay? So this will be really easy and streamlined, as you can see. And now we're just gonna go here and test in progress. Hopefully this will measure up to 10K. 10K, you have about 10.03 kilo ohms. Nice, and that's their value. Leave them in their packaging. If you take them out, test them before you put them in, because if you don't know how to read the color codes on here, you're pretty much going to be blank out of luck. Okay, and this one 1007, 10.07 kilo ohms, which is fine. We're on a roll. We only got one bad, dead, damaged capacitor. Bummer though, because with the glasses, they actually sent us 2. You know, like they knew it was going to be a dead one in there. 10.05 kilo ohms on the resistance. And then we're just going to go here. Press it again. We got 2 more resistors to check. And we have 10.02 kilo ohms. One more after this one, and we got yep, 10.10. Nice. And then we're going to test this one. One more batch of resistors for the resistance, and then we'll go here. Great, so that one tested out okay. Good, we are on a roll. Now for the 1K. Again, leave them in their packaging, or this little strip of whatever you call it, so that you don't get mixed up. Okay, it's really nice that they did that for you. There have been some kits I've gotten where you have to do this to each one. no matter what. Test in progress. 1K, 1 kilo ohm. Nice. And those will go into its corresponding spot. And then we have here testing. We got 4 more after this. See? 1K. 3 more after this. Test in progress. Again, there's no rhyme or reason. The reverse polarity, you can put this in any direction and you will be golden. But if you want the colors lined up a certain way, then do it like that. Okay? Knowing that and moving forward, 1K, 1.01. Wow, that one's cutting it close. Would have been a 99. And we got here. Nice, 1.02. And then last one. That's it for the resistors, for the resistance. And come on. Yes, we did it. All right. All right, now we're good with that. So we're good with the resistors. We're good with the transistors. The capacitors, one was dead, or as they say, damaged. All right, and now we're going to test these capacitors. There are 4 capacitors measuring at whatever this will give, and then 1 random one. Okay, minus is negative. And let's see. And then the plus side is the long side. Shouldn't think it should matter. Test it. Test in progress. This I don't have any extra ones of, unless I take something apart. Nice. So this is it even tells you the percentage of loss. So 1.5% loss of like its reading, and it's a capacitor of 103 farads and 57 ohms or users. So we have 103. So let's see what's on here. All right, so we got 105. So at our 1.5% loss, that's good. This is the 105 capacitor. I wonder if I put it on in reverse, what we're gonna get, like the reading, right? Does it matter? Nope, we got a 104. Okay, again, this is the 105, and there should be 4 of them. So we got 1. Okay, now we're gonna measure the other one. I'll just keep it continuity. It shouldn't matter. We'll just measure it. But when you put them on the board, negative is negative and positive is positive. Okay, you can't mess that up. Measuring them, I don't think it matters. Okay, test in progress. Nice, 106. It's a little off, but you know, like it said, 1.5, and that's not going to make or break your experience with the transistor radio. Okay, that's 2. Remember, we got 4 capacitors. Okay, and then we're going to go here. And we're going to measure. We got 2 more after this. Just going to test it. Test in progress. And nice, 106. And then we have 1 more. Test in progress. Remember, 4 of the same. We got 4 105s and 1, I'm not sure what that number is, but we'll check. Wow, 110, interesting. And then 1.1 percentage off, supposedly, but that's more than 1%. All right, knowing that, moving forward, we're going to measure the other one because it should have measured 105 instead of 110. All right. Interesting. And this one is a 2.9, oh, it's a 1.0 UFs, and so 1 farads, and then so let me just make sure. I have to look on here. So small, so hard to see with all these little letterings on here. Yep, 1 UFs, 1 farad. Okay, the other one I wasn't sure about, but I believe, yeah, it goes 100, 100, 100. So they're a little off, 100, but it's fine. They're not dead. So we measured these parts, which are good. We applied a little tape to the chip, right, so that that experience will be somewhat streamlined, as you saw, right, so that when we tap it with the soldering iron, it's going to make a nice connection. We have our speaker, which is fine. You know, we could always make the wire longer or shorter. That's not going to be an issue. I believe it's already got its soldering joints. We can always check on the little instruction thingy that will tell us where the parts actually go when it comes to soldering the speaker, especially if there are 3 connectors. When you have 2 wires. Interesting. Okay, because as you can see, I'll show you guys. So on the speaker, you got bummer. At least on this thing. That's why I say always check the parts. See, on the speaker, we got 2 connections, a positive and a negative, which is fine. But then here, we have 1 wire that goes here, and then 1 wire that goes there, which is fine. But as you can see, you have 2 in the middle, and 1 on the left, and 1 on the right. So on here, you can't see. Remember this picture? No wires are in the middle. Okay. And now if we go here, you've got solder there, which is fine. No solder there, so it could be confusing. You're like, wait, which one is, where does the solder go? Was 1 left and 1 right? And so going this way, this side is the positive side, it has the plus, and the minus has the minus. Okay, knowing that, moving forward, the plus side is there, minus is there, but you've got solder right about there. So I would just, you know, you might be able to apply more. You should be able to, or if you can't, we'll see when we put it together. If we can't, we'll just scrape it a little so that the or add some flux so the solder would adhere to it. We'd have to do that with the LED lights that we build. All right, knowing that, moving forward, I could always prep that later before the show. But no, you guys need to see how it's done because we're going to be building it live. Here are the connectors. The scoreboard, it looks like there's a chip in there. It'll tell you how to put the chip in. Sometimes it can be confusing because you would think like, hey, I should just put the chip in, you know, corresponding to the design. Sometimes not. Sometimes you gotta go against your instinct and just follow the directions. And as you can see with these, the dot, right, there's a little dot here. The dots go facing down, so it'll be 9. You know, they distinguish like a decimal. Okay, and as for the chip, usually it goes according to the moon shape thing, and we'll cross that bridge when we get there. But all this is sealed, so we're going to leave it sealed for now because we'll be doing this on the next video. Then you have here USB-C micro connector. You can charge it if you have maybe rechargeable batteries, or you could use this as a power source. But make sure you use the power that's here. You know, like don't overdo it. Like I think we blew something up the last time when I applied too much power to the clock. So 1.3 and 1.3, right? And it'll tell you how many volts is needed to power this thing in the specs slash hold on, direction, right? Let's see if we can scroll up, look at the schematics. Sometimes it's on the schematics. 2 AA batteries, which is fine. Working voltage is 4.5 to 5.5 volts. You over exceed that, then shit's gonna just blow up. So make sure, and that would probably be powered, so that means you could power it from the USB port on your computer. Okay, knowing that moving forward, we'll cross that bridge when we get there. Remember, we're just testing parts to make sure that they work. Speakers, I doubt they would short out, so I'm sure they work. And you have 4 buttons. See this right here? You have 1. Okay, put it right there. 2. And then you have 3. And then you have 4. Then you have buttons that go on top of the buttons. But I believe these aren't buttons. These might be potentiometers. Yeah, they're little dials. Don't touch that dial. We'll be back probably for volume. What else? Turning the station. And I'm not sure what else you would do on the radio. But we have 4 dials. I know volume, turning it up, turning it down. But I don't think you need a different dial to turn it down. Let's see what we have here. S1. Okay, S1 is volume up. Oh wow. S2 is volume down. S3 is frequency. Oh, so it's not one dial to control the volume. It's one dial to control volume up, and another dial to control volume down, another dial to turn the station up, another dial to turn the station down. All right, it is what it is, but it's supposed to be really cool when it's done. And then we have a little switch here. You could always use the continuity experience to test the switch like you would apply. I wish this thing beeped, but there's no beep on it, but I'll show you how in a second. See, I don't have those clips for this meter. It never came with one. You could use alligator clips, right? Let's see if we turn it on. Here's the meter. Make sure your chips are not in the way. Remember, these chips are gold because that's the brain and the life force. And you find the on-off. Sometimes some have on-off, some don't. So you have to take a lucky guess. And if you put 1 meter here, and then 1 meter there, see? Let's see if we shut it off. And then turn it off and off. We shouldn't get any reading. See, nothing. Turn it on. See? So one way's on and one way's off with its reading. So let's see. It's tricky because you don't want to touch anything. Oops. So you would just like touch it like that to get the experience of on off as the switch is making its connection. See? And then we'll touch it again and we get nothing. And that's because one's on and one's off. So this is, see, I'm touching it, nothing. Flip the switch. It's measuring continuity, and we got to be, so the switch is good. Just don't bleed the soldering connections, otherwise it's not going to work. It'll be like doing that to it. And that's it. I believe that's all the parts. I mean, the most of the parts. I'll show you some a little more. We have a headphone jack. I'll see if I can find my headphone jack. My headphones that would go into this. I think I have one somewhere. No, I don't know. But if you have that kind of technology laying around, you can test it with that. You have another potentiometer meter. I'm not sure what that one is, to be honest with you, but we can check it out by finding out where it goes. R1. Another potentiometer. Okay, just different. Smaller. I've never seen one like that. I usually see them different kinds of switches. Alright, and then I believe that's it. So this is going to stay like this until we we build it again. I mean, build not again. Actually, this will be our first. Oh, and one more piece. Hopefully, we don't have to build it again. The antenna. You must learn how to build the transistor radio. All right. So on that note, I believe we've covered all of the parts for this particular lesson. And keep everything organized. You don't have to keep them the way I have them in this video. Keep them in a way that makes sense to you. Like, you know, some people can find the parts all scattered in a box. Some people need to have all the parts, you know, aligned so they can just grab and go. So, you know, this is a video that's just going to help you with your soldering skills. But when it comes to technique, everybody has their own technique and skill set when it comes to keeping organized. But ideally you want to keep them organized, but you don't have to put the potentiometer here, the speaker there. Put it in an area that calls out to you, that says, oh, I like it better there, and then that works. As long as you can build this without blowing it up, that's all the power to you. Okay, knowing that and moving forward, I'm just double checking a couple of pieces here, because even though it says 100 100 100, some of them, only a few of them say 100. Like one says 105. 100 on the side. Okay. It could just be the shrink wrapping. All right. Knowing that and moving forward, I believe that's it. Just organizing everything so that it's good to go when we are ready to go. It's going to be fun, challenging, mind-boggling, and a headache at the same time, if that makes any sense. Little adhesive you have for the speaker once you put the speaker on, and we'll test it before we put it together, because you don't want to close it up and then find out that either a resistor's wrong. Not resistor, because there's no, well, resistor could be wrong. There's no right or wrong way to solder them in, but you could accidentally solder it into a wrong place, and that's why you don't move on to the next resistors until you finish the ones that you're installing, if that makes any sense. Okay. I have tweezers just in case, and I believe that is it. That is all for today's lesson. Put everything back. Anyway, I'm looking forward to building this transistor radio. It's going to be an experience of a lifetime. So remember, don't touch that dial, and remember to tune in when we go live again to build the transistor radio, your stoop box, your beatbox, your portable radio station that you can take with you, because remember, it's powered by batteries or USB, micro USB powered. If you have a little portable power adapter you can take with you that can convert the conversion rate so that the experience is just right for you. Anyway, if you have any comments or questions, feel free to leave them down below, or ideas for other videos. Remember to like and subscribe, and I'll see you all next time. That's it. Show is over. Alright, just gonna stop the stream. I'm gonna definitely put the old parts in here just in case. I don't know, just for memories in case I do another video and people want to see what a damaged part is when reading that meter or any meter. I'm sure we have a dead LED somewhere from our previous kit. I know I didn't throw it out, but I know I probably mixed them up in the bag of goodies. There's a case, but the case will be part of the closing ceremony when this thing is put together. That's it. Be well, and I'll see you all